Hi, this is Edip. I'm not very comfortable in talking to camera without class interaction, especially teaching logic, because it requires some feedback, whether I am going too fast or too slow, whether you don't understand what I am saying. I will try it. This is on chapter 9, Methods of Deduction, from Copy's book, Logic, Introduction to Logic. I have been using this book. This is the most commonly used, most popular textbook in logic in the United States since decades. I've been using this for about 14 years. In my previous copies, one of them, I have extensive notes. I don't put notes anymore in the margin. And this is the 11th one. I have a lot of notes in the margins. In fact, some corrections. I wish I had let the authors know, and I should do that because they need to get those feedback. Now, rules of basically methods of deduction. We have 19. We have rules of inference. 9 of them, simple, elementary units of thinking and deduction. And also we have 10 rules of replacement. The book, because of its importance, the book puts in the back, and here are the rules of inference. 9 plus 10, you will end up 19. And here it is. I want you to see this paragraph because it's very interesting paragraph. The word complete is very interesting. It is mathematically shown. This is not kind of an arbitrary thing. The 19 rules of inference that have been set forth, 9 elementary argument forms and 10 logical equivalences, are all the rules that are needed in truth functional logic. Together they constitute a system of natural deduction that is compact and readily mastered. You can teach the computer these rules, but nonetheless complete. Big assertion by logicians. This means that using this set of rules, one can construct a formal proof of validity for any valid truth functional argument. Got it? Okay, 19 rules. We are basically born when these 19 rules embedded in our logic system, in our brain. Now, this first section, I want to introduce you the first 9 rules, which is rules of inference. The others is help us replacing them, and in order to intuitively, very easily make judgment about statements and arguments, whether they are valid or not. Okay, the first rule is very famous, is Modus Ponens. I'm putting here, and the top section I want to allocate, keep it there, and then do exercises. While do exercising, you will see the rules here, okay? Therefore, the first rule is Modus Ponens. Modus Ponens. I hope I can fit them here. I don't know whether right under each other or not. Let's try it. Modus Ponens is what? Basically, if P then Q, you say P. I don't put this line, there is no reason. I got habit of putting line between the premises and conclusion. Therefore, Q. Okay? Modus Ponens. If P then Q, it is P, therefore Q. You can make up many arguments like this. For example, if the car is running, then it has gas. The car is running, therefore it has gas. Basically, P stands for what? For a statement. Q stands for another statement. They are statements or propositions. And when they are used, when we use the statements or propositions in an argument, we call them premise. Now they are functioning a part of the argument, premises. And this is the conclusion Q. This is Modus Ponens. And there is a logical fallacy kind of resembles Modus Ponens, it is like a wolf disguised like sheep. Beware of that. It's one of the mostly very popularly committed one. This one, we call it if P then Q. P is what? You remember from previous class? P stands for, we call P antecedent. Q is the consequence of a hypothetical statement. If P then Q. I don't want to go back too much, but first I want to a little bit remind you what were the rules, not rules, symbols. We learned about this one, P and Q. It means you assert that P is true and Q is true. If you tell a kid you are very smart and also you are very handsome, or someone, your boyfriend or girlfriend or wife or husband or friend, you are very smart and you are handsome, that means you assert that both are true. If one of them is proven to be false, in this case, is really, there is no proof for either way because it's very subjective assessment. Okay, well, let's make it different. For example, let's say the United States is #1 is military spending in the world, and United States is #1 in K-12 education in the world as of 2013. Well, P and Q. The P stands for what? United States is #1 in military spending in the world. This one is #1 in K-12 education. When you combine them, you mean you assert both of them to be true. If one of them is false, then the whole statement considered false, because it is a compound statement, and means you assert that both of them to be true. In that case, as we know as a fact, that yes, United States is #1 in military spending, in fact outspends all the countries of the world, but in K-12 education is not even top 10. The last time I checked, Finland was #1, and then I think South Korea was the second one. And therefore, since you assert both of them to be true at the same time or at the same place, then the whole statement becomes false. But if you say United States is #1 in military spending and the capital of the United States is Washington, D.C., well, this whole statement will be true. One of them being false, make it false. But P or Q, oh, I'm sorry. This is for or, we use like V. P or Q, this is loose connected, means this true or this true. Both of them could be true, still you are true. Your statement is true. One of them, P, could be true, this could be false, still you are true because you said one of these at least. Or Q is true, P is false, still your statement true. Your statement will be false in only one case. What is that case? When both of them are false. If you are a politician, if you are a religious demagogue, charlatan, use this one. Put many statements next to each other with or. If one of them being true by chance or somehow you know, the rest of them could be lies, still your whole statement will be true. Because this is like this. This is like parallel carrying something, let's say a weight, P, Q, R, S. Let's say P, Q, R. Well, let me put two. Don't confuse you with others. Okay, this is P, this is Q. Two strings holding a weight. Well, let's say one of them is enough to hold the weight. When you cut this one, still one of them holding the weight. Or make an electrical connection, let's say circuit. And the electricity comes from here and this at the same time and goes here. Therefore, if one of them is broken, the line is broken, the cable, still this one let it go. But in this one, it is serial connection. This is P and this is connected to Q, two wires, and then here is let's say, lamp, and the electricity coming through here. If one of them is broken, that's it. The other, how strong it is, doesn't matter. Therefore, P and Q and R and S and T, if you put 5, 6 statements and the conjunction is and, then you assert all of them be true. Your opponent can attack the weakest one, and if prove that that is false, the weakest statement in this conjunction, conjunctive basically statement, compound statement, that's it. They proved all your statement to be false because you asserted every element, every component of your statement to be true. Therefore, that you must be very careful when you connect with and. The other one we learned is a symbol if P then Q. You remember? If P and then Q. This is, we call it antecedent, the consequence. This means what? It is not the case that if it is P and not Q. That means if it is P then Q, you say if it is marker, then it will write. If it is marker, then it will write. Okay? But if it is marker, someone says, yes, this is marker, and check it, doesn't write, says it doesn't write, then that person proves me to be false because I asserted that if it is marker, it will write. All the time it will write. But let's say he grabbed this one, say this is not marker and it is not writing. Well, he didn't prove me false. I'm still default true, my statement. Or he got a pen and wrote it down on paper, says, well, this is not marker, means this is false, but it's writing, the writing is true. Well, am I wrong? No, I didn't say anything about pencil. Therefore, in this case, even false, he picked the phone, not the phone, let's say he picked this one, tried to write with this one, it didn't write. This is not a marker and it didn't write. False, then false. Still, my statement stands. It's not proven to be false. Okay, and another one we learned tilde, let's make it use it P. Not P means not P. Means if this is true, this make it false. If this is false, if P, the statement P is false, then this makes it true. Okay, as a reminder. Now let me erase this one, go to Modus Ponens. This was Modus Ponens. The second one is Modus Tollens. I just put abbreviation. If it is, okay. I was going over this one, let's Modus Ponens. If P then Q, this is antecedent, this is consequent. We say it is P, you affirm the antecedent. And then you say Q. Makes sense. But something that disguises the logical fallacy, we call it affirming the consequence. That's a logical fallacy. Means if it is P then Q, instead of P you say it is Q, therefore it is P. You go from backward. By affirming Q, you go back to P. No, it doesn't mean that. For example, if it is running, then it has gas. It has gas, therefore it's running. Makes sense. This is valid argument. But something looks like that, it is false. Let's say if it is running, it has gas. It has gas, therefore it is running. Not necessarily. It doesn't say it is only it is running if it has a gas, or if it has gas only and only if it has gas it will run. Well, it doesn't say only, it doesn't have restrictions, something like that. Therefore, there is kind of a false assumption of a restriction such an only, reading this one like only if Q, which is this symbol, tribar, we'll learn later. Okay? Okay. It is called the fallacy of affirming the consequent. In some cases, affirming the consequent will make sense, but sometimes it will not. Therefore, it is not a reliable form. We call it logical fallacy. We avoid it like plague. Modus Ponens is, let's put here, if P then Q, it is not Q, therefore, 3 dots, it is not P. Think about statements. If P, then Q. Well, if it is lemon, then it is sour. It's not sour, therefore, it's not lemon. Something like that. Well, if premises are true, the conclusion must be true. Some of the premises can be questionable. Of course, you can question the conclusion. We are talking about validity, not soundness. Soundness means the argument form is valid, is a good formula. Also, the premises are true. If premises are true and it's valid, we call it sound. Here we are not talking about soundness. Therefore, don't worry about the premises I say. My premises may not be 100% true. Sometimes could be argued, then it is an issue regarding premise, not the form. But we are talking about logic, validity. Okay, modus ponens. It has also another form of it, which is fallacy. Looks like that one, but it's not. Like it is. If it is P, then Q. It is not P, therefore not Q. That means denying the antecedent. That's bad. Think about examples. Make up several different examples. I don't have time. I would like to indulge, but I want to finish this as fast as possible. Focus on the topic. We did it in the past, giving many, many examples. I want you to generate your examples. Give examples from fruits and animals. Or, for example, if a person is honest is a statement. Now put if a person is honest, then that person is happy. Person is not happy, therefore the person is not honest. Now let's make it logical fallacy. If person is honest, then the person is happy. The person is not honest, therefore he's not happy. Not necessarily. You didn't say only if the person is honest. It doesn't restrict that one, but if person is honest, you affirm that one, then this one, basically like this one. Anyway, let's go to hypothetical syllogism 3. Hypothetical syllogism. Syllogism, you know, an argument with two premises and one conclusion. An argument with two premises and one conclusion is called syllogism. Okay? If you were here, perhaps you would ask or not, but I have to preemptively strike some possible question. You should know by now, but anyone who just watches this video may be curious. I want to also address them. Hypothetical syllogism is this. If P then Q, if Q then R, another third statement. P is first statement, Q is another statement you are making, and it is hypothetical, conditional. And then another statement enters R, therefore, you can say if P then R. Really, this is simple. It really means like this. In elementary school, you can say, if P then you go to the Q, then from Q you reach to R. Well, it means from P you reach R. You see, P goes to R through Q. It's like this one connected with this one, 3 hooks, and this is R, this is P, this is Q. Okay? This logic very makes sense. I don't want to give examples. Examples, you can generate as many examples possible. If you make examples from fruits, animals, the things that you know, you will be able to understand that whether it is valid or not easily by trying different things. You remember about the sets, bigger things like animals under the mammals. Sometimes change mammals and animals, make antecedent, consequent, change them according to the bigger set sometimes first, and then you will see some problems that time. But if you talk about certain terms like honest, just, Republican, Democrat, that one it will become difficult to sense whether there is problem there or not. That time it is very useful, these kind of things. Okay, these are very elementary. If you don't understand this one, if you study it, there is problem with your logic board. If you are not born as a deformed person, I wonder whether you watch until here, you will not have patience. It will be most likely during very early age, either your parents or school or your priest or your mullah or your rabbi played with your brain, opened hole, enter a lot of fallacies and superstitions, a lot of contradictions, or did not let you think and question, flourish as a child. Please, let your children ask question why and why and why. Why question you should celebrate, you should encourage. Okay, and fourth, disjunctive syllogism. Disjunctive syllogism, I just put the abbreviation. Disjunctive syllogism is P or Q. It is not P, therefore it is Q. P or Q, it is not P, therefore Q. Simple. P or Q means either of them is correct, or both of them. Minimum, one of them is true. Well, P or Q, you say, you assert that this is true. The second assertion, it is not P. Of course, what's remained? Q must be true. Therefore, if these two true, this must be true. This is another elementary logic rule. Number 5. And this one, constructive dilemma. Constructive dilemma. Constructive dilemma means we have a dilemma. If P, then Q, in parentheses, and then if Q, R, let's say, R, then S, we have 4 statements. They are connected. This is the major, the main connection. Do you see it? I'm so sorry. I need to make it a little bit higher. Okay? Hopefully. Okay. Then here, from here you can say constructive dilemma. It is P or R. Therefore, it is this or this. At least one of them is true. And of course, you can, from this you can say either Q or S. Then one of the consequent will be also true. Consequent. Does it have plural? Perhaps not. Okay? Antecedent, consequent. Maybe in this case we can use it as a noun we are using. Okay? If P then Q and if R then S, well, P or R is true. P or R. It is true that P or R. Well, one of these true. Well, if this is true, Q is true. Must be, cannot be false. Because there is and here. And requires this to be true, this true. Is this hypothetical is true? Well, it means this is true and this is true. But if this is false, this must be false. But here we say what? Either P or R is true. Well, if one of them is true, Q or S, one of them must be true too. Lovely. Okay? And 6. 6th rule is, we call it absorption. Absorption is basically very interesting. I don't know how. If P then Q, therefore P, if P then P and Q. From here you can reach this one. Of course, if P is true, then Q is true, you say. If P, then Q. Well, it means what? If P is true, then both of them is true. This sounds You may think it's so common sense, but it is useful in evaluating very complex arguments. And number 7, wow, I may fit all of them here. Number 7, let's call it simplification. Simplification. P and Q, therefore P. Lovely. P and Q, do you see it? Okay. If P and Q, okay, P and Q, therefore P. Of course. You assert both of them to be true. Therefore, you can say therefore P. Of course, you can say therefore Q too. But as a standard usage, we do this one. If there are two statements, we can simplify, we can move this one to the other side to affirm that one. But just for standardization, we use P here as a conclusion. And what is, we have also is 8 conjunction. You say P, Q. You say P is true, Q is true, then you say P and Q. If P is true, if Q is true, the conclusion is what? P and Q, both of them true. P is true, Q is true. And then we have also simplification. We have also simplification. Simplification? No, this is, which one is simplification? This one is simplification. This is conjunction. This is conjunction. And we can have also addition, I think. Addition. And it is P, therefore you can say P or Q. What? Yeah. P is true when you say, you can say P or Q is true too. The value of Q is not important. It's irrelevant, it seems. Because Q, if false, it doesn't change the truthfulness of P or Q. Because you assume to be, you claim to be asserted that P is true. Of course, if one of them is true in disjunction, you remember, parallel circuits, one of them is enough to conduct electricity. In that case, you can add. This is called addition. These are the 9 rules. Now I want to go exercises. I want to give a space. I want to write down, because for writing we spend time. I want to write some examples. First, I will go on exercises to simplify some very complex looking arguments to check which one of those rules they are. Then we can easily say it is valid or not. Okay, see you next section. I don't know whether in the middle I will put something or not. Take care. Hello, this is the basically some exercises these are still simple. We're going step by step, more kind of difficult, especially going towards the end of the chapter. You will find it is very delicious, but you need to kind of learn step by step. It looks very complex, but they're very simple. To really be able to read this as one of these simple ones, to be able to look, let me see whether we have here, okay. Now let's check the first one. In parentheses A and B, this is a conjunction. If A and B, if both A and B, then C. Therefore, A and B, if A and B, then A and B and C. Well, this is, for this one you can, this is the main operation. This is the main operation. Basically, for this one you can put P, this is Q, C for Q. Therefore, P, then P and Q in parentheses. Which one is this? You remember absorption. Look at here. If P then Q, therefore it is P, if P then P and Q. It's exactly the same thing if you simplify. For compound statement conjunction A and B, you can call it P. No problem. As long as the main operation is the same. Therefore, or here, this could be or, could be and this could be false, true, doesn't matter. You call this as a one unit because this is exactly here. Therefore, whatever the truth value of this A and B is, it will be here. Therefore, you can call one P, the other P. It is a statement, the same truth value. We are checking the truth value of this. Therefore, this was absorption. As far as for this one, I don't want to confuse you with this much. Okay, this is P and Q. You see, this is the main parentheses show this is one side, this is another side. Basically, this is conjunction is the main operation. And this or that. Well, this and that. Oh no, look at this one. This is this one. Therefore, P and Q, this means what? P and Q, therefore P, D or E is P. Which one was this? Simplification. Do we have simplification here? Yes, here it is. See how easy we're there? What about this one? Well, here we have, for whole these, with the negation we can call it P. This whole thing is Q, and of course, it is this one in the middle, P and Q, and this is what? Therefore, P. But I erased here something. Anyway, with this one, like part of it. This one is the same. This one. Therefore, don't be confused. You can call the whole bulk of this compound statement which is negated J. It is not the case that J and K, and if L, then not N. Well, for this first part, you can call it P, this is Q, and conjunction, and then you can get one of them, which is another simplification. What about this one? All goes to the recognition of the main thing. This is this one, and this becomes what? P, if P then Q, it is not Q, you see? For all these things, I call it Q. I didn't say not Q because in the standard form, we don't have not Q. Why not call the negation Q, but negation of negation, which will become affirmative, is Q2. No, not Q. This was Q, correct? Not becomes not Q. Therefore, this is not Q. Well, if P then Q, it is not Q, therefore not P. Lovely. This is modus tollens. Modus tollens. Look at this. If P then Q, if P, this is P, then whole thing is Q. Now we said not Q. This whole thing was Q from here to here, correct? This is Q. Not Q, which is, we wrote down, and this is P, you see, X or Y, not P. And this one, I don't want to talk much, think about it. It's P, then Q, it is P, therefore it is Q. Modus Ponens. This one, P, then you see I called Q, P. These are written in capital letters to a little bit make you not get confused. You can use minuscule. Therefore, this is, if P then Q, it is R then Q, therefore, and. Do we have something like that? This one, constructive dilemma here. It's not constructive dilemma. Am I sure 16 is that? Okay, let's see. Try to find out. Write down here. This one I'm writing here. If P then Q, this is R. If R then Q, therefore, if P then Q, R then Q, therefore, this one, and this one. Okay, this is P then Q, P then Q, and R then Q. Okay, lovely. It looks very confusing, but it is not. This whole thing, if P then Q, if R then Q, then you got the conjunction. Well, the whole thing, you can call it P. In fact, this whole thing P, this whole thing is Q, and then, as here, you got this one, this is really P and Q. Isn't this cute? Therefore, we got conjunction. This whole thing you end up initially, I tried to make this component P and this is Q, but it didn't fit to any of my standards. But if I make this way, it is valid because this whole is repeated here. And this whole is repeated here. Well, if you affirm this is correct, this is true, you affirm that this one, the second premise, is true, of course the conjunction of both of them will be true too. This section also done. Now we are going to formal proof of validity. We are going to do some exercises. I need to erase it. I don't want to waste this precious recording time. Meanwhile, you can have few seconds of thinking. Hello. I put 3 questions here. It says on page 347, read the instruction, says, each of the following exercises presents a flawless formal proof of validity for the indicated argument. For each state, the justification for each number line that is not a premise. This is another step to construct our own proof of validity, formal proof validity. Here it is done for us, basically after the conclusion, it is the proof of validity because you justify the conclusion. Look, this is the conclusion X, you end up with X. Conclusion is not I, and this should be not I. Well, it's 8, not H. Oh, not H. I'm sorry, conclusion is not H. I look at the wrong place. This is, and this is justified. Basically it is made for us the proof, but it is not told, we are not told which rules have been used step by step to reach the conclusion. Okay, let's look at this. This is basically 2 premises, A and B, and then second premise says A or C, if A or C, then D. And the conclusions A and D. I want to give you a real life example. By the way, make it more difficult for you, you can make it simpler. For example, Fethullah's cult turns smart people to idiots, A. B. Capitalism and consumerism is responsible from climate change, or air pollution and space pollution, water and ocean pollution. This is B. A. The F-type cult, or let's say cult, makes people stupid. B is capitalism pollutes the environment. Simplified. And then I say, the next one is, if cults turn people to stupid, Or now another ABC, the fourth statement, we could say corporations like useful idiots once uses stupid people. Then D, then the third world countries will fill with religious cults. Let's say this is D. And then the conclusion, A and D. Cults make smart people stupid. D and D, and the Middle East is filled with cults. You can make it much simpler. A and D, you can say, this is a banana. B, this is milk. For example, like that. Okay? Make it simpler. But I made a kind of some political statements. You can say this complicated argument, whether it is valid or not. Okay? Now let's look at it. Now we want to justify this conclusion. When we just try to justify this conclusion, we do not involve this one. We want to reach this one. We can only use these two. You see, third one somehow derived A to be true. Well, where it comes from this. A and B, basically number one is called simplification. You see, in simplification, P and Q, you can write P. Therefore, instead of A and B, since both of them must be true, you can say A is true. Therefore, each step, we can assert the truthfulness of it. We don't know the conclusion to be true or not, but we have to assume that the premises are true in order to be a valid argument. What is the definition of valid argument? If premises are true, the conclusion must be true. Now we are going to check, assume the premises are true. Let's see whether we can reach to the conclusion by using this simple elementary level of deduction. Now let's see, A or C, where we can get this. Well, we can get from the third step by what? Look at this. By addition. You see P, any proposition, a true proposition, you can add to it through disjunction anything you want, false or true, doesn't matter. Therefore, A or C is addition. You can add C. The value of C, truth value of C itself is not important. We don't know C is true or not, doesn't matter. Because we know A is true, one of them is true is enough for this, the whole thing to be true, this chunk to be true. And then, let's see how D is derived. When we look at it without this help, this is basically help. The next step, we will look at this and we say how this conclusion can be derived is through these basic forms. Okay? D. Aha. Ah, look at this. If A or C, then D. Well, we know that A or C now is true. In the fourth step, we got this to be true. Initially, we didn't know. Therefore, now we... Aha. A or C is like P, then Q. For A or C, write P. For D, write Q. And now we got this one. A or C, it is P. Therefore, it is Q. And how we got D from here? By using 2 and 4. These two of them is Modus Ponens, correct? MP. By using Modus Ponens, we're able to derive D. Modus Ponens between which ones? Between second and fourth. Now let's check whether we can add D. Well, we know A is true, we know D is true, therefore we can connect them through conjunction. It is called conjunction. Basically 3 and 5 conjunction. This is how you justify it. Let's go next one. I'm going to use black. Don't fall asleep, please. Don't answer your phone. It's not right now. You need to be able to focus. You can chew the gum while watching this and engaging in. But come on. Don't eat food. It's too much distraction. You may spill over yourself. Okay, my dear student or my dear friend. Let's go over this one. This is, you see, 1, 2, 3, 4 premises reaching the conclusion, which is X. If W then X, this is one proposition, this is another one. And then we have if then, wow. We have too many propositions. You cannot get out of them easy. But if we can step by step, by using these, we can reach to X, fantastic. It's already made it easy for us. At this step, we are just trying to understand the mind of the person who proved that. And you should be able to generate all these rest of the steps. You see, we don't number this one because we cannot use the conclusion for justification, because conclusion, that's the one we want to justify. We want to reach the conclusion. Now, look at this. The first step says, if W then this. We have W here. WX, aha, it is so easy. Let me make some room here. Here it is, my dear friend. This one, correct, number 1. We can do what? We can do absorption. Look at absorption. If P then Q, therefore you can say, if P then the conjunction of P and Q. Lovely. This is absorption. Why we did this? You see, we'll be using this one as a step for here. You see, we got W and X. Now you understand why from this simple thing we made it even more a little bit complicated, it seems. But this really, intuitively, you should be able to deduce from here to here. And now we got this one. Now, if W then Y, if W then Y. From where you got W then Y? If W then Y. Okay. Am I right? Did I put it right way? Oh, let me see whether I made a mistake. I'm right now not in a good shape. W then Y and Z, okay. I don't have my answers. I didn't, so first time I'm if I'm not on my elements, I may not be able to solve this simple stuff. I didn't prepare. And this basically even numbers are not answered in the question in your book. In your book you will have 1, 5, 10, the answers. Therefore, I don't use those ones in order to give you more examples. Let's find out this one. Now I am going to be embarrassed by the whole nation, which is good. I don't claim to be omniscient, knowing everything. But let's see how we got W, if W then Y. If W then Y. I think from here we can get, look at this. We have these two from here to here. Oh, no. WX. Lovely. Look, this one and this one. I change it. Look at this. This one and this one. Basically, and then from here we can jump here. W then Y. Are you sure? No. Then that. W then 1, absorption. Okay, this one reaches this Y, and I will come back to this one. Somehow I got a glitch in my brain. Let's go this one, whether I can solve it. I might be out of battery. I need some glucose. Okay, let's go here. Are you able to transfer here? Now we see 4 premises and not H, not I or not H. Not I or not H. Well, if this is true, number 4, we can add this one, correct? Not I, we know it is not I to be true. We can add anything without knowing the truth value of H, not H, because through disjunction, and this is called addition. We can add anything here after this one. Okay, we got that one. Not G. Well, that's simple. We know this one. This is if P then Q, and we got Q to be true. If P then Q, it is, and then it is Q. We don't have such a thing, correct? We cannot go backward. We cannot have, it is a fallacy. It is not Q. Okay, not Q. If P then Q. Oh, we need to be true. Therefore, this must be true too. Correct? This whole thing is if P then Q, then it is P, therefore it is Q. And we are going to use 3 and 5, this one and this one, do you see? These two to reach this one. Basically, if P then Q, not G is Q, you end up with Q because you are using this one. It is what? Modus Ponens. Modus Ponens. 3 and 5, Modus Ponens, lovely. And then not F. Well, okay, if H, then G, not G. From here, we know that not G is what? Is true. Therefore, G would be not G. G will be true. And if G is true, not G will be false, because double negation make it true. Therefore, not G is false. And okay, not G. Therefore, this one is what? Is modus tollens, negation of Q. Therefore, 1 and we need to find not G, 6. And modus tollens. I'm sorry, I'm going here. I apologize, I should push here. Is this one 1 and 6 F. And modus tollens is this one. You see, if P then Q, not Q, therefore not P. If P then Q, not G, we call it Q, that's okay. And then it is not Q, therefore not P. And modus tollens. And now we have if H then not G. If H then not G. Okay? Well, not F, correct? If not F, and then you affirm this one, you can get this one. Therefore, 2 and 7 is modus ponens. Look at this one. Anyway, it is 2 and 7. Look at 2 and 7. Basically, for not F, you can put P. Do you see all of it? Okay. And then, if P then Q, this whole thing, call it Q. And you say it is P, therefore it is Q. If P then Q, it is P therefore Q. This one is modus ponens of 2, 7. And then you can get not H from where? H, then not G. Okay. Well, this one we threw 6, I think 8. You see, 8 first. Let me put 8 first to the order of the standard 8, 6. If H then not G, it is not G, therefore it is not H. And not, okay, 8 and 6, negation of the Q, therefore modus tollens. Okay, modus tollens. Modus ponens, modus tollens. If you have kids, call their names modus ponens and modus tollens. If you have a boy and girl, both boys could be one of them modus ponens. If my wife was agreeable with me, perhaps I give that name. By the way, I tell my student, if I decided to put a tattoo on my body, I would put these rules of inference, these 19 rules of inference, you know, this one, I would tattoo it on my chest. And then during class time, I would take my shirt off and walk in the classroom, let students get inspiration from that. But it seems I'm too late for that, for such crazy things. I'm already married, I have kids, and not. But I may do a little on my arm. I love this.